Welcome back to Urevise, where we talk about everything exams. Let's take a look at question 41D and E from the 2016 exam. The question reads, nitrogen dioxide is toxic to humans when inhaled and is a significant component of air pollution. It can be formed by combustion of nitrogen in the air at high temperatures, firstly forming nitric oxide and on further oxidation forming nitrogen dioxide. The overall equation for this process is given here. The following questions relate to the equilibrium system represented by this equation. The questions read, on the axis below, draw separate curves to show how the concentration of the three gases change with time, starting with the moment the oxygen and nitrogen gas begin to react with each other until the system reaches equilibrium at time E1. Continue the graph from time E1 to E2. Assume that the initial concentration of oxygen and nitrogen is identical. Label clearly the line for each gas. At time E2 shown on the axis, the reaction vessel is doubled in volume and the system is then again allowed to reach equilibrium at time E3. On the same graph above, show how the concentrations of the three gases would change in response to the change in volume from time E2 until equilibrium is re-established at time E3. Okay, according to the examiner, 4,926 candidates attempted the whole of question 41. The mean score was 10.74 out of 18. Many candidates failed to label either graph, resulting in loss of marks. Probably the labeling of graphs, I've left this one, the labeling of graphs is just a problem, but even though the question states you need to clearly label the graphs, graphing skills in general were poor. Curved lines were not smooth and straight lines were not straight and horizontal. Many candidates did not demonstrate a strategy to plan and draw curves, and some displayed a poor understanding of what was happening within the system. So, for example, what was happening when the volume was doubled, etc. And part D, the most common omission was not showing the 1:2 ratio between nitrogen and oxygen. So if we look at the equation shows us that for every mole of nitrogen that reacted, 2 moles of oxygen were being consumed. So which means the graph showing oxygen must be steeper. And both curves starting at the same point, right? So it clearly says oxygen and nitrogen starting concentrations are identical. Yep. In part E, common omissions was the decrease in concentration for all gases, which is what the examiner was saying here when they were saying students did not show an understanding of what was happening in the system. So when we double the volume of a vessel, we are decreasing pressure, and by so doing also, the concentrations are going to be forced to go down as well. So we need to see all the gases because these are gases here, so the concentration, which is the partial pressures of these, will also go down and they'll decrease proportionally. Those that have got a higher concentration will be affected more than those that have got a lower concentration. Okay, let's move on and look at the answers to this question. Now let's take a look at the actual answer after breaking down the question and looking at the examiner's report. Now, we are asked to draw separate curves to show how the concentrations of the three gases change with time. And this statement here tells us that oxygen and nitrogen gases were in the reaction vessel, there was no nitrogen dioxide, which means these ones start with a higher concentration, but nitrogen dioxide will start at 0 concentration. And also, we are supposed to assume that the initial concentration of oxygen and nitrogen are identical. So the initial concentration of nitrogen and oxygen, we can pick a spot right high up there to say probably that was the concentration, because we can pick any spot as long as it's gonna produce a graph that depicts or shows what's happening. We are supposed to clearly label the line for each graph. So for the first set of the drawing, or first part of the drawing, we are supposed to go from get to time E1 and continue the graph between time E1 and E2. Now, another thing we have to bear in mind is the graph for oxygen, or the curve for oxygen, is supposed to be steeper than that of nitrogen. So the gradient for this one is going to be a steeper gradient than that for nitrogen. Why is that? Because there's a 1:2 ratio. If in the reaction 1 mole of nitrogen gas is consumed, right, double that is being consumed of oxygen. So the concentration of oxygen is going to drop at a much faster rate than that of nitrogen dioxide. If you were really drawing this accurately, you would find also the gradient of this and of oxygen and nitrogen monoxide should be roughly similar, but that's not really important. The only thing where we're supposed to demonstrate the difference in gradient is between nitrogen and oxygen. So I'm going to pick a couple of points to say, okay, since oxygen is going to drop more in concentration, I'll say, okay, it will drop up to this point when it gets to time E1, and nitrogen drops up to that point. So between these points here, this is my strategy. I try to use some dotted lines that will actually come and give me a curve that runs up to that dotted point. This one is for nitrogen, and I can have another dotted line as well before I actually draw it properly. Now my curves look like what I want them to look like. So what do? I can then now draw this curve like that, following the dotted lines so that it's getting up to there. And do I need to do the other one as a dotted line? The answer is no, because not necessarily actually. Why? Because if I label the graphs, the examiner is going to see which graph is representing what. So I can pretty much do all the graphs, draw all the graphs in the same way. So this one is O2. Now, when we get here, the system has reached equilibrium. So these lines will now be horizontal lines, which I said in one of the questions, use a ruler when you're doing this on paper and try to make these lines as horizontal as you can. Now, the nitrogen dioxide, as these ones are colliding, nitrogen and oxygen are colliding here and their concentration dropping, that is, they are being transformed into nitrogen dioxide, which I'm just gonna draw like this here. Okay, actually not a good idea. I abandoned my plan. I need to pick a point. That's why it did not work for me. Have the dotted lines. Yeah, and then this one should be a straight line that shows the system has reached equilibrium. I can leave it like that if I want, and label this nitrogen dioxide. And then this is it for that question. I've done everything that the examiner wants me to do here, and I can now proceed to part E. Part E goes on to say, at time E2, show on the axis the reaction vessel, at time E2 shown on the axis, the reaction vessel is doubled in volume, and the system is then again allowed to reach equilibrium at time E3. And on the same graph above, where it says above, but we'll know that it's on the left because I've rearranged this for the screen, show how the concentration of the three gases would change in response to the change in volume, right? At time from time E2 until equilibrium is reached at time E3. Now, what we need here to look at is if you increase volume, the overall concentration of these gases will drop, okay? And this nitrogen is going to be impacted more because it has got a higher concentration followed by oxygen. Now, since I have lines here on my screen, I can say, okay, I want nitrogen to drop 1, 2, 3, 4, 5 steps just below oxygen here to this point, and I will drop oxygen all the way up to maybe there. I'll drop it 1, 2, 3 paces, and this one I can drop it 2 paces like that. So oxygen, I'll drop it up to here, and that one I'll drop it up to there. I'm just separating this so that you can see what's happening here. Now, we need to show how the system responds to this imposed change. What do we do? Just draw this neatly now that I've explained. Try to remove these dotted lines because they're getting it look a bit messy. Right, okay. So what do I do here? Let me actually draw this in different colors. I'll draw this one in blue. I said I'm gonna drop it up to here. And this one, I'll draw it in the red. I'll drop it up to somewhere here. And then this one here, I'll just leave it at where it is right there. Let's get rid of this and redraw that like that. It follows this. It can't drop as much as oxygen. I'll drop it just two lines. Okay, now having done this, how is the system going to respond? If we look at the equation that we are given right here, where I'm clearing up so that we can see what's happening. On the reactant side, we've got 3 moles of gas, and here we've got 2 moles of gas. Because this is a gaseous system, at equilibrium, it has a certain amount of pressure. If you halve the volume, it means the pressure is going also to be halved, because pressure and volume are directly proportional. So the system wants to go back to that pressure that it had originally. The only option is for the system, according to LCP, Le Chatelier's principle, the system will try to partially oppose that imposed change by shifting towards the side of the gas which has got a lot more moles of gas. So nitrogen dioxide is going to be consumed. When nitrogen dioxide is consumed, its concentration will keep on dropping, while the concentration of oxygen and nitrogen will increase. So this is what we're going to see happen. This one will start going up, right? But it doesn't go back up to where it was originally because the LCP says, the principle says it partially opposes the change, so it gets somewhere up to here. And then the other one as well does the same. It doesn't actually get back to where it was at equilibrium E1, E2. It's going to go, let me get a red one to match that color of the graph. So this one goes down 3 steps. When it gets here, it starts going back up, but it doesn't actually go back up to where it was originally. I don't like that curve either. This is where the tricky part is, because I abandoned my game plan. I need to use my game plan. Right, so this one drops 1, 2, 3 up to here, and then it goes back up like that. You see, if you stick to your strategy, it works. That has worked fine for me. And then this one will keep dropping like that until it establishes equilibrium, right? So this is what my graphs are going to look like. I'm just gonna go over them because I'm happy with what I have here. Considering the circumstances, I've drawn this to the best of my ability. No, that's not the best of my ability. I'm lying there. Let's try again. Like that. Now, okay, that's all for these two questions. I shall see you when you come back to attempt the next question. Thank you once again for watching. I shall see you in the next video. I hope this video was very helpful, and I would love to hear any questions, any concerns, or anything that you think could have been done differently in this video.